Hey, good afternoon, class. Sorry I can't be there today. I really wish I could, but I'll be back soon. Hopefully, you guys had a great Thanksgiving. Hopefully, you guys enjoyed your break and kind of rejuvenated some and are ready to finish off this semester strong. We have almost 2 months left of the first semester. Today, we're going to talk about congruent figures, which obviously are congruent polygons, and one of those polygons that we'll focus on are going to be the triangle. So the first thing, let's talk about congruent polygons. Congruent polygons are polygons that have congruent corresponding parts. So that means congruent figures have the same size and the same shape. If two of these congruent figures are congruent, then you should be able to slide the figures on top of each other, rotate them, or turn them on top of each other, or even flip them, or if they're mirror images of each other. You can see that mirror image in this example with the quadrilaterals. So you'll notice that we have two different quadrilaterals. They are flipped. You'll see that C corresponds to angle R and B corresponds to Q. That also means then angle X is going to correspond to angle Y, and angle A is going to correspond to angle P. You can also talk about in terms of the sides. AX, the side here, is going to be congruent to and correspond to PY over there. Now, the way that you name these figures is very important, and you need to make sure you go in the right order. So if we start with A, and we move counterclockwise, ACBX is going to be congruent or corresponding to PRQY. So now let's try this on our own and try to figure out what's going to be congruent to each other. So we have triangles TJD congruent to triangle RCF, and there are congruent corresponding parts. And remember, you need two things. You need sides to show that they are congruent, and you need angles to show that they are congruent. And again, the order of the letters matter. So TJD, I'm going to number them the order in which they're written, 1, 2, 3. RCF, 1, 2, 3. And that may help you determine what angles are what and what sides go where. Because obviously these two figures are not exactly the same positioning, but they are the same in terms of lengths and angles. So in terms of the sides, we can say TJ is congruent to RC. JD is congruent to CF. JD 2 to 3, C to F 2 to 3. Then we can say D to T, which is 3 to 1, is congruent then to FR. Now in terms of the angles, angle T is going to be congruent to the angle 1 on the other one, which is angle R. Angle J is going to be congruent to angle C, and angle D is congruent to angle F. Now, if I go too fast, please feel free to have the substitute pause the video, rewind the video throughout the notes. I also posted this on the My Weebly page, so you could go there, you could find it, so you could go back through and listen to it tonight if you so choose. Alright, so letter B is asking about two triangles, and we want to figure out what their congruent parts are. Again, we're going to talk about in terms of their sides and their angles. We don't have any figures. So what I would do is draw two figures. And I'm going to draw them so it's just a slide, to make it easy in positioning. W, Y, S, M, K, V. That's our 1, our 2, and our 3, our 1, 2, and 3. But now they're in the same position, it's going to be easy to find. WY is congruent to MK. We're going to have YS is congruent to KV. And then SW should be congruent to VM. Angle W is congruent to angle M. Angle Y is congruent to angle K. And angle S is congruent to angle V. Alright, so for example number 2, it says that we have the fins of a space shuttle. And these fins suggest congruent pentagons, which they should be congruent if they're fins of the same space shuttle. You want the fins to be the same. So what we need to do is figure out what the measure of angle B is. Not quite sure what that is. But if I have congruent pentagons, we got to figure out what is corresponding to what. Well, this looks like we just flipped this figure on top of this one. So if this is angle B, what's in the same position on the other fin? That's going to be angle E. And if they're congruent pentagons, we can say angle E is congruent to angle B because they are corresponding parts. And I think that's going to help us out. Why is that going to help us out? Because on this figure, we know what all of these angles are. We're just missing one. And you guys are smart enough to figure out and remember from last week what the interior angle is, and we can of this pentagon, and we can figure out what angle E is. So if you remember, n minus 2 times 180, which is really 5 minus 2 times 180, or 3 times 180. That's going to be equal to 540 degrees. But that's the entire pentagon. So we have to add up all of these angles